Well, thank you for coming. A few familiar faces, people that seem to come along to my little workshops every year, so thank you for that. Gluttons for punishment or something like that, I guess. So the schedule, a little bit late. We'll start with part 1, 11 o'clock, so in just under 2 hours we'll break for coffee, and if the past performance is anything to go by, there may well be cupcakes. And actually, one of the reasons why I think people keep coming back to my particular talks is that I've learned this lesson that if you let people out about 3 minutes early, they get to the cupcakes first, and that makes them like you. And then, so half an hour break there, we'll be back at 11:30, and then it's a slightly uneven split. So I guess in the last 20 minutes we'll just we'll review what we've done and maybe answer some questions and things like that. And then 11:50, there's another short break, and then you can all go off to something else. Okay, so what we're going to cover, I put this on the description on the website, so you may have seen this. An overview of Perl and the Internet of Things, little talk about introduction to web clients, building web APIs with Dancer, an introduction to REST, and then digging a little bit more depth into writing REST APIs using Perl. If anyone doesn't want to do that, then now's a good time to leave. Okay, so this is what we're supposed to be talking about, Perl and the Internet of Things. So what's the Internet of Things? Well, there's things, and they're on the internet, and they provide some kind of useful service. What was that stupid robot rabbit thing that used to sit there and light up when you got email and stuff like that? If you want to know some more about what it entails, it's a very good book. Both of the authors are here today. They're running the Arduino workshop most of the day, and then Hakeem is giving the keynote at the end of the day. So there's quite a lot of hype around the Internet of Things at the moment. It's a cool thing that everyone is into. So people are, it's all really cutting edge interactions. Everyone talking about all the latest technologies. People using really modern, up-to-date languages to write this stuff, things like Scala and Erlang. You hear people talking about writing their Internet of Things code. Well, the reality is that when you actually strip this down, in 95% of the time, the Internet of Things, all we're talking about is an HTTP transaction. There's some event that triggers an action on your device. The thing makes an HTTP request to some server. The server sends a response. The thing does something. So going back to the robot rabbit, was it the Nabaz tag or something like that? Nabaz tag.
I think so.
Yeah. It would wake up every once in a while, send a request to a server saying, "Do I have email?" And it gets a response back. And if it says yes, then the rabbit lights up and twirls its ears or whatever. So actually, when we talk, because all we're talking about is HTTP transactions, any language works. And Perl, of course, is just as effective as other languages. Because Perl has a long history of writing HTTP server applications and HTTP client applications. So Perl is a great language for doing this kind of thing. And of course, with anything that you look at with Perl, part of the power of it is the fact that we have the CPAN, and there are loads and loads of useful modules that solve many of the problems that you might otherwise have. I don't know if there's anyone here who has never seen me give one of these talks before, but please feel free at any point to stop me and ask questions and correct me if you think I'm wrong and you want to make me look really stupid in front of the rest of the class. So, the unusual thing about Internet of Things transactions is that your thing, whatever it is that you want to put doing useful stuff on the internet, although it's an HTTP client, it's not going to be a laptop computer or something like that. But it's going to be your HTTP client. But it's going to have a slightly unusual interface. You're not going to have keyboards, monitors, mice, anything like that to deal with. You're going to have some kind of more limited input-output channel. Maybe some sort of hardware sensor. You get these days teddy bears that listen to what a child says to them. So it's got some kind of microphone, and it's then it's unlikely that the teddy bear has the processing power inside it to analyse the speech, so it's actually sending off to a server to do that kind of thing. So it's very likely that actually within your Perl program, the input that you're taking from the outside world is going to come in through a serial port or something like that. So there's a module device serial port that you can find on CPAN. More specifically, there's a device, BCM2835. Does anyone know what a BCM2835 is? No, it's the input-output chip that you'll find on a Raspberry Pi. And quite often, Internet of Things are built out of something like the Raspberry Pi. Of course, there might also be an Arduino, but if you're interested in Arduinos, you'd be at the Arduino workshop right now. And actually, is anybody here because they couldn't get into the Arduino workshop? So it's difficult to give any specific advice about the kind of inputs that you'll be going to be getting from that your thing is going to be getting, because each device has its own problems and ways to work around them. So I'm not going to be able to dig into the hardware side of things, or even the interfacing to the hardware side of things today. What we're going to be looking at for the rest of the morning is going to be the HTTP stuff. So the other thing, of course, about your thing, it doesn't have a keyboard, it doesn't have a mouse, it gets its input through strange devices. But also, it's not going to be displaying the web pages. So if you make an HTTP transaction, the response it gets back, it's not going to be showing a web page. But I suppose in some rare cases it might be. You can imagine a toy with a screen of some sort on it. But generally it's going to want to parse the response and get useful information out of it. So returning HTML, which is what we're generally used to doing, is generally going to be pretty unhelpful in this case. You want something of a more data-rich representation to send back to your object. In most cases, that's probably going to be JSON. And that's what we're going to be assuming today. Okay, web clients. By web client, of course, I mean a program that, I guess the best way to describe it is a program that pretends to be a browser. It's a piece of software that's acting as initiates the HTTP request and then passes the response. And that's what a browser does. It sends an HTTP request saying, send me this web page, gets the HTML back, and turns it into a web page. We can write software. So when you think of web programming in Perl, you tend to think of web server programming, which is writing the software that sits on the web server and produces the output and sends it back to the client. And we will be covering a little bit more about that later on in the morning. But Perl is also good for writing web clients, which, as I say, they are the programs that act like a browser. They make an HTTP request, they pass the response, and then they take some sort of action. If it's a real browser, that action is displaying the web page to you. If you're a robot bunny, the action is wiggling your ears and flashing lights. So when asked to write a web client in Perl, most people would reach for LWP. That's the default standard, the de facto standard for web client programming in Perl. Stands for libwww-Perl, which is the World Wide Web library for Perl. And the name has been, well, the origins of the name are lost in the depths of time because it's been around for as long as I've been using Perl, which is a very long time. And it's powerful and it's flexible. And is there anybody here that hasn't written code using LWP at some point? A couple of people. Okay. It's an interesting exercise to go through at some point. And it's in CPAN, on CPAN, so you can download it and install it from CPAN the way you would any other module. And that's fine, and it's there, and it's well understood, and people have been using it for decades. But I want to talk to you a bit more about HTTP Tiny. Has anybody ever used HTTP Tiny? A couple of you. HTTP Tiny is a small web client for Perl. And it's part of the standard Perl installation, or has been since about Perl 5.14 or something like that, I think. There you go. Of course, Tiny is good for the Internet of Things because your software, your client software is going to be running on a Raspberry Pi or an Arduino or some small system on a chip type device. So although they're not completely rubbish, that they aren't the most powerful devices in the world. So we can keep our client software, the things that are running on the thing, we can keep that as slim as possible, and that's all for the better. So HTTP Tiny, being a cut down HTTP client, is actually quite good for this use case. So here's an example of using HTTP Tiny, and if you've read the documentation that comes with it, you'll know that this is very lightly edited from the synopsis. So we create a new object, and then we immediately call the get method on it. Then we can interrogate the response for success. There's a Boolean flag for success. Or we can get the status code or the response reason, which is just the text that goes alongside the status code. There's a hash reference called headers, and that's key value pairs of the headers we can get back. As you'll see here, each of the headers can potentially have multiple values, in which case the value you get back is an array reference. So we're just being a bit clever here to work out whether it's a scalar or an array reference. And then finally the content is in this key called content. So you can pretty much do all the things that you need to do for basic HTTP client work with this slimmed down HTTP client library. And the reason that it was added into the Perl core was because they decided that as part of the installation of Perl, it would be nice if Perl could do some HTTP calls. And there was some talk about adding LWP into the Perl core, but that's a big thing to add into the Perl core. So instead, somebody came up with HTTP Tiny, which is a much smaller thing to add into the core.
So what do you lose by choosing Tiny over LWP?
Some of the complicated things that nobody actually ever uses in LWP.
Did you get all the
Callback functions for processing.
did you get all the stuff like cookie management, all that kind of stuff? Or was that all
I'm not sure. Well,
right.
yeah, you might have to do cookie management yourself, in as much as you'll get the cookie back
in a header.
In a header, store it
nice cookie jar or anything
somewhere,
like that.
and then you can add it back as a header on the way out. So just to drill down into this into a little bit more depth, so we create a user agent object with new, obviously. You can pass in a hash reference to some configuration options. Actually, it's not a hash reference, it's just a hash. The options it takes, you give it a user agent string. As far as I know, well, I guess there's two reasons why people change the user agent string. There's the good reason, and then there's the bad reason. The good reason is that you want to tell the owner of the website that you're visiting that you are some kind of automated system, a bot, and identifying what the bot is and where they should go to report any problems. The slightly bad reason is websites that actually check the user agent string and will only let you in if you are a browser, for example, and you can change the user agent string to make yourself look like a browser, or look like a particular browser if you want to force the Internet Explorer return. The history of user agent strings is fascinating. I don't know whether, I don't know whether it's still true, but for a long time, Internet Explorer included the string, the string Mozilla in its user agent string, because there were, back in the day when Internet Explorer was new, there were websites that wouldn't let Internet Explorer in because they were checking for Mozilla. So you can use that to work around those kinds of restrictions. Of course, in these enlightened times, nothing like that ever happens anymore. Actually, you can give it a cookie jar object, or any object that responds to the similar methods that cookie jar does. You can set some default headers as a hash ref. Some lower level things, you can set the load address, keep alive flag, redirections, maximum size of the response, these kinds of things. Timeout in seconds. It handles all the standard proxy options that you'd expect. It also honours the environment variables in the same way that LWP does. You know, you set an environment variable called HTTP_proxy, and it will use that. You don't need to pass it in. And also, if you want to delve into SSL, there's a couple of SSL objects. It uses this IO socket SSL under the hood to do SSL transactions. And I guess, although this is the only thing I'm going to say about SSL in the whole morning, but if you're the kinds of things that you're doing in an Internet of Things transaction might just be the kind of things that you don't want other people sniffing across the public internet, so SSL might actually be a pretty good idea to use as a default when you're writing this kind of code.
Do you do compression?
Compression? No, that will be one of the things that you want to reach for LWP. So we've got a browser object, effectively a user agent in the parlance, and it has a request method, which is what we use to make our request. We pass it the method, a URL to make the request to, and then some options. There's a number of options. The most useful ones are obviously the headers, so that's where you might want to put the cookie stuff. And content, so obviously in a post, then you're going to want to post content to the URL. Also in a put, things like which we'll be getting to in a bit more detail later on. And the response you get back is a hash. Now, those of you that have used LWP will know that the response you get back from LWP is an HTTP response object. And that's fine, and that works great. And there are many, many good reasons why dealing with this stuff as an object is a really good idea. But one of the things that they've done with HTTP Tiny that strips it back and makes it not as heavy as LWP is that they've made the response into just a hash, an unblessed hash. We saw some of the keys in that hash earlier. So there's the success flag, which is just set to a true value if the response code is, well, it starts with a 2. So it's not just 200, but any of the other 2XX responses that mean that things were successful. There's the URL, which is the URL that actually returned the response. Now, given that we've made the request to a URL, why do we need to know the URL that returns the response? Redirections. We might have made a request that got redirected a couple of times before we finally got the response. The status code, 200, 404, 500. The reason, not found. Okay. And actually the content, which is what you actually want. Oh, and also within the response hash, there is a hash reference, which is a reference to a hash of the headers. Any questions on any of that? Good. That's all very well and good, making requests using the request method, but it actually has higher level functions for making requests that are called get, head, post, put, and delete. So these, for those of you that know HTTP, those are the main HTTP methods that you can make. And in your normal day-to-day web processing, writing web servers, I suppose, you tend to write code that responds to gets and posts. You might occasionally write code that responds to a head, or if you're writing a client, you might occasionally run head, because that just returns the headers. But it's quite rare in the general run of things, until now, to use put and delete, but later today we'll see more reasons why you might want to write that kind of code. Is there anybody that has written either a client or a server that deals with puts and deletes? A couple of You're writing web services, I guess. So each of these methods is a shorthand way to call requests. So we can call get URL options, and it's exactly the same as calling request get URL options, just a shorthand. Takes the same options and it returns the same response hash. So we might want to post data to our web service. And we can do this, or we can do this, but where do the post parameters go in this situation? In a GET, the parameters go actually on the end of the URL, you know, ampersand, something equals something else. In a post, the parameters need to be put inside the options hash because they are part of the content. When you're learning web server development, probably the first time that you come across a post is when you are uploading a file, and the actual contents of the file need to go in the body, the content of the request. So it needs to be put into the content key in the options hash. But you have to build it yourself, which is a bit clunky, a bit hard work. You have to encode it in the correct way. But it does have a helper method called WWW-form URL encode, which you pass a hash of the keys and values, and it builds up the content value for you. But there is actually an easier option because it has a post form method, which has, you pass it the URL and then the form data, which is a scalar. It can either be a hash ref like this, or an array ref like that. The difference between the two is that if you pass it an array ref, then the method guarantees the order in which the content, the parameters will turn up in the content. Whereas if you pass it a hash ref, well, of course, it can't guarantee the order because hashes are unordered. I would contend that if you're writing web server software that depends on post parameters arriving in a particular order, then you're probably doing it wrong. But of course, you have to deal with other people's web server software, so we give you that option. A few other bits and pieces that sit around. Try HTTP Tiny. There's a HTTP Tiny UA, which adds some higher level user agent features onto the module. HTTP Thin. So currently, the request method in HTTP Tiny is completely different to the request method that you would find in the LWP stack. But by using HTTP Thin, it adds this really thin wrapper that gives you HTTP request and HTTP response compatibility. There's even an HTTP Tiny Mech, which is a www mechanized wrapper. Okay, so that was just a really quick introduction to web client programming with HTTP Tiny, which is, I guess, a module that not many of you had seen. Any questions on any of that before we move on to the next section?
How about with like near real-time devices, would Tiny be suitable?
Near real-time devices? Yeah.
Or choosing Perl will be a mistake with it, the real-time.
Well, if that kind of performance is important, then I think you'd probably be wanting to look at something, a completely different sort of architecture anyway. but you don't know for sure until you've tried it.
Sure.
And I think HTTP Tiny would probably get you closer than LWP would. Dancer. I love Dancer. The Dancer, is there anyone here who here has used Dancer? A few of you. It's a really lovely, simple, root-based web framework for Perl. I say Dancer, but I actually mean Dancer 2. There are actually two modules on CPAN, Dancer and Dancer 2. And Dancer is kind of the prototype, and Dancer 2 is the version that really works well. But they, rather than just releasing a 2.0 version of Dancer, they decided that they would split it, and they've got two completely separate development tracks, so that people that have written stuff, and there's plenty of stuff out there that's live in production that uses the old version of Dancer, so they've still got a upgrade path to fix bugs and stuff like that. So Dancer 2 is a completely separate namespace on CPAN. Dancer makes it really easy to get your web app application up and running. If you're interested, then pretty much immediately after this class finishes, at 12 o'clock, Andrew Solomon is doing a workshop about Dancer. And so if the little bit of Dancer we do in the next hour or so whets your appetite, then have a look at Andrew's class to get the full story, or at least a fuller story than I have time to do. And also, it's hands-on, so you'll get to try it out. Is anyone planning to go to that anyway? Yeah, so we're actually going to be using Dancer 2 in the examples that I show, for the reasons that I've explained. Okay, so the API that we're going to be writing returns information about MP3s. Now, those of you who have seen my classes before know that whenever I talk about databases, I have examples based around CDs. But it got to a stage where I was having too many people come into my classes that had never owned a CD. So I've had to update it, and now we're talking about MP3s. So we're going to support things like get MP3, which will return a list of all of the MP3s in the system, and get MP3 with an ID, which will get the information and probably slightly more information about an individual MP3. Now I wrote this is just as kind of just an example, but on blogsperl.org just a couple of days ago, Ovid wrote a really interesting blog post about why it's a bad idea to expose IDs like that in your web interface, because it gives people an easy way to start hacking the system. If you return some values for the value 1, then it's easy for people to just change it to a 2 and try and see. Which, you know, if it's MP3s that you're showing information about, that's perhaps not so much of a problem. But if it's a customer's data, for example, a little bit more of an issue.
For MP3s, it might even be a benefit.
Sorry?
For MP3s, it might even be a benefit.
Yeah, there are situations where it might be a benefit to make your URLs hackable in a good way. So we're going to keep this really simple, and we're going to create a database. This is a SQLite database. It just has one table in which contains data about the MP3, ID, title, artist, and the file name. So it's not even normalized in any kind of meaningful way. I don't really have time to go into DBIX class, but DBIX class, DBIX class schema loader comes with a program called dbig dump, pass it various options, and it will generate all of the classes that you need in order to talk to your database. So in this case, we've told it to dump stuff into lib by connecting to this database, mp3.db, and then if we do a find in lib, we see that it's generated, well, basically just two files, the main schema file and then a result file. And those are the two classes that we will then use to talk to our database. And then insert some sample data, and this is just the three songs that I decided to include. ID, title, artist, and then the file name. Dancer is like many of these modern Perl frameworks in as much as it gives you a command that you can use to generate a skeleton for your application. So you type dancer2 gen for generate an application called mp3. And it does a load of stuff. This is what I've missed out, because there's quite a lot of files it generates. But I've just pulled out the three files that are actually going to be of interest to us over the next half hour or so. The configuration file, the main library file, and then that's the application file, the program that you actually run to start your web app. Which we can do by just running mp3 bin app.pl. Dancer tells you that it's listening to on your local host on port 3000. You can go to port 3000 and your application is up and running. I always like to point out at this point that Perl framework development teams, like the people behind Dancer, have actually learned from frameworks in other languages. If you think back to early Perl frameworks like Maypole, the default application that you started up was absolutely ugly. But they put some effort into generating a default application that actually tells you what the next steps are to take, and gives you some useful links to things to find out how to take the next steps. But obviously our application doesn't do anything, it just sits there and looks pretty. That's probably a metaphor for something, but I'm not sure what. So we need to start implementing our actual routes. The routes are defined in, this was one of the files that I pointed out that it's generated, the mp3.pm file. And if we look in that file, there's a bit of other boilerplate, but the meat of it is here. And this is Dancer defining a route. And what this is saying is when someone does a get on the root of the, and that's root with R-O-O-T, whereas this defines a route, R-O-U-T-E, so that's not going to get confusing at all. So this is saying when someone does a get on the main route of our website, run this piece of code. And this piece of code is really simple. It just says use the template that's called index and return that. And index is something else that is, if we look back to here, then one of the files that I missed out was the index template. And if you look at that index template, it's got all of the HTML to create this largely static page. I say largely static because it's got a little bit of JavaScript in it. So yeah, get on route, run that piece of code. And that's how Dancer routes work. This is what makes Dancer really simple to understand. But we're going to ignore the root and write our own roots. We're going to start by writing the MP3 root, which is going to generate a list of MP3s. So we'll get them from the database, which means that we, one of the great things about, well, CPAN and Dancer in particular, well, not Dancer in particular because all of the frameworks have it, is this wonderful ecosystems of plugins and extensions. So you think, oh, I want to use DBIC within my Dancer application. I wonder if there's a plugin for that. Oh yes, look, there's Dancer 2 plugin DBIC. And what you do is you, in config.yaml, you just add this section telling it what your database is. And then in mp3.pm, we write a root. Is there anyone that's not pretty happy with DBIX class stuff? You've all dabbled at least with DBIX class. Okay, I'll dabbled. Dabble's
no, not production.
No, fine. So what this says is when we run get on /mp3, we run this piece of code. So let's talk through what's in this piece of code. So by adding Dancer 2 plugin DBIC, it's giving us a couple of keywords that we can use in our code, and one of them is schema. And those of you that know DBIC, you'll know that the way to talk to a database in DBIC is through a schema object. So this gives us the schema object that is connected to the database that's defined in config.pm. And the other thing to know about DBIC is that if you want to, so in comparison to raw DBI, in raw DBI you have a database handle which you talk to the database, and then you have a statement handle which you use to actually run a piece of SQL. DBIC's slightly different. You have a schema object to actually talk to the database, and within a schema object you get a result set object, and you use that to actually fire SQL at your database. So we've got the schema, and you ask the schema to give you a result set, and we want the result set for MP3s, so that's basically the MP3 table. And in our simple method, our simple toy example we've got here, where we know that we've only got 3 MP3s in the database, we just call the all method on that result set. In production, you may want to worry about paging and stuff like that. So we've got basically we get an array which contains, well, each element in that array is an MP3 object. It's a DBIC style MP3 object that contains the information about one of the MP3s in our database. Does everyone understand all the DBIC stuff? That's about as complex as we need to go with DBIC. Then, just because I can't be bothered with HTML, because we're doing Internet of Things type stuff and HTML is useless, we're just doing text plain. So we've switched the content type to text plain. I have, for over 15 years, I've had a massive, I don't know, it annoys me that do you remember all those really bad teach yourself Perl and CGI in an afternoon books that filled the bookshelves 15 or 20 years ago? All of them would print out content type HTML and then just print plain text out to the browser. And I never understood why they couldn't just get that one simple thing right. So we're going to be printing plain text, so we're going to tell the browser, or tell the web server that we're returning plain text. And then we're just going to return, joining with new lines, and we're going to map our MP3 array, and for each of the elements in the array, we're just going to print the title, a slash, and the artist. So I said that inside our MP3 array, we've got these DBIC style objects, and one of the things that a DBIC object has is it has a method on it for every column in the database. So we can just print out the title and the artist. Everyone with me on that? So get MP3, there's the schema, change the content type. And when you run it and go to, let's zoom in, when you go to localhost 3000 MP3, then you get back the text of our 3.
In the previous page you had used a schema. Is that just a built-in?
It's a built-in that gets added to Dancer when you use Dancer plugin DBIC.
Right, and configure it in...
And configure it in the config.yaml.
Yeah, okay.
So by adding about 4 lines of code to our database, to our application, we now have our MP3 endpoint working. So let's, flushed with success, let's move on to the next one and deal with what happens when you want to look at the details of a particular MP3. So Dancer gives us a really easy way to parse parameters out of our path. So I've called it up here /mp3/:id because that's the way that you configure it in Dancer. So those of you that have used some CGI.pm, and I'm sure you've all done some CGI.pm at some point in the past, we'll recognise this kind of style for getting hold of parameters. So here is our new route. So we've changed, or we've added. This is a new clause in the code. So we're getting mp3/id, and what this says to Dancer is if someone does a get on a URL that looks like this, where it's /mp3/something, then run this piece of code. And our code here is quite similar to what we've done before. So we're calling schema to get the result set, but rather than getting all of them, we're just using the find method on the result set to get the MP3 that has the correct ID. So the name of the parameter here is whatever name you define it to have up here. And we just get, obviously, a single MP3 object back. Or we might get no MP3 object back if that ID doesn't exist in the database. So what we do here is, unless we've got a value here, we set the status to 404 and we return not found, and the browser will get a 404. And then, well, pretty simple stuff. Again, we set the content type, and then we print out the title, the artist, and the file name. So status is a keyword that Dancer gives us to set the status. And again, if we browse in, if we zoom in and we go to mp3.1, then it's given us all of the details about one particular mp3. So now we've written 15, maybe certainly less than 20 lines of code, and we've really got the beginnings of our API going here. Yeah, let's address the issue of plain text. That's really not what we want to return. We talked right back at the start of the morning about doing something that was a bit more data rich and asking our internet thing to parse plain text is bad. As I said, there's an easy fix. This goes in the config file. We say no, serialize the data that you send back as JSON. And then we need to make some changes to our routes so that instead of returning just text, we actually return a Perl data structure. And if we return a Perl data structure, then because we put the serializer as JSON, Dancer will automatically pass those data structures to a JSON encoder on the way out. So here is the MP3 route. This bit's the same. Again, we're returning something. Right. So it might be slightly complex to unpick exactly what's going on here. So maybe I've got, yes. So what we're returning is a hash reference. The red braces mark the start and end of a hash reference. Within that hash reference, the first key is MP3s, and then the value associated with that key is a array reference, as you've got the start and end square brackets. And then within that square brackets, within the array, we're passing our MP3s array into a map function. So the map, for those of you that haven't seen it, is basically a machine for converting one list into another list. You give it a block of code and a list or an array, and for each element in the array, that gets stored in at underscore temporarily, sorry, dollar underscore temporarily, and whatever your block of code returns gets substituted for that element in the output array. So we've got this map block of code, and what we actually do within that block of code is create a hash reference. And in that hash reference, we get the title and the artist. So, whiteboard. There's a whiteboard. Well, there's a flip chart. What we end up with here is a hash. Well, there's a hash that has only one key, MP3s, and the value in that hash is a reference to an array. That array ends up with 3 elements, each of which is a reference to another hash. And that has title and artist in it. So we're actually building a reasonably complicated data structure. There's another one of these here. And another one. So instead of returning the text that includes the information about the MP3s, we've now turned it into this data structure. So everyone follow the... And the fact that we end up with something that's quite brackets heavy here is it just takes a little while to unpick exactly what's going on. But you're all up to the task. You're all system. Then we need to also change our individual mp3 route. Again, this top bit is still the same. We're finding the mp3 and returning a 404. But what we're returning here is just it's just a hash reference containing the details of a single item, title, artist, file name. And then I realised actually that because what I'd got was a DBIX class result object, and a DBIX class object actually has this useful getColumns method which returns you a hash reference containing the name and value of all of the columns.
You mean a hash, because you've got curly braces.
So it returns you a hash containing all of the columns. We've actually, there's a difference between that and that. Can anyone spot what the difference is? In that, yeah, there's a subtle difference in the
Returns ID as
the
well?
return includes the ID, because there's a column called ID which we're not including here. But and so if we run this and go to mp3, then we get back the JSON. Obviously, it's not particularly well formatted. Sorry, question.
Can I just clarify? So, by default, if we are returning a Perl structure, so the answer chooses JSON.
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 Dancer chooses JSON because we've put that serializer JSON
Oh, did we in the config?
in the config. Yes.
Okay, so if we want YAML, so we would just put content type YAML under that root, and it would turn it into
Yeah, but
user.
actually hold that thought because we'll see other
Okay.
ways to do that later on. If you didn't have, and I did this whilst I was developing this test application, if you return a data structure, like a hash reference, as we are doing here, and you don't have the serializer JSON in the config, then Dancer tries to interpret what you're returning as HTML, and you end up with a hash reference on your web page, which is not useful. And if we go to mp3.2, then we get a hash reference. Yeah.
So can you actually override then the type of return type? Because I know we JSON encode here to actually get this, but if you want something else, not the type of just straight HTML, I know that now we've got in the config, we've got JSON.
Yes. So anything that's in the config file, you can override in your code
Right.
with a set command. So if you've got JSON configured and you decide that actually for this route you want to return HTML, then you can do set serializer HTML.
And that would be just in the sub. Would it now you
Yeah.
do that?
I suddenly realised that I've been writing all this code and testing it as I've gone along. Now I've changed the serializer to JSON. What I didn't test was what happens if I then try and visit the main page, which has still got that HTML template. So JSON will try to, so Dancer will try and convert that to JSON, and probably won't work.
Have you
No,
tested
it won't, because it's that you've returned the template there explicitly. The index page tells it to return the template, which it knows how to use. It'll only serialise something that returns an object, I think.
I think it'll only serialize something that's a reference. But,
Oh, okay.
but I am curious to see what would happen on your 404 page.
I would hope it's template built in.
Because you've just got return string. So if you go back to the code on your
Here.
unless mp3 status 404 return not found, is that content type HTML?
I'm sure the JSON
With
serializer would know what to do with that.
plain
wouldn't
text?
it?
Is it-
No, I think I tried it and it did send me
Sent you JSON.
the JSON,
Yeah.
but it was late at night and I might not have tested it quite so
I'm sure the JSON serializer can handle a string, right? I would hope.
Well,
Did it return the correct
Well,
status
actually,
code?
sorry?
Did it return the correct status code as well? Did
Yes.
you got a JSON 404?
Yeah.
I think so.
That's what I did.
But there's more stuff later on, which actually may be what I'm remembering.
as a complete aside, I really like most browsers have a plugin called JSON View, which makes it so that this gets prettified automatically in the browser, which is really handy.
Right, what time are we coffee breaking? Not for 45 minutes. URLs. So it's good practice to return a URL in your data whenever you can, because if you're returning a chunk of JSON and you've got a client that's parsing it, and your JSON includes information about something else that they might want to get more information about, then rather than just including the ID or the name of that object, it's a good idea to return a URL so they can directly just do a get on the URL to get the information that they want. So we can do that for our list on our mp3 page. So what we've got here, again, we're getting all of the mp3s, and then we're getting the base URL for this page, or this route. And URI4 is a dancer keyword. I say keyword, it's a subroutine. They make it look like a keyword. And then we're doing all the normal stuff here, but we've just added this on the end here. So it includes the URL of the, if they want to get more information about that particular mp3. Oh, and I've done a get here rather than the browser, so that I can show you a little bit better. And so here we've got the title and the artist as we had before, but we've also got this URL coming back in the JSON, saying if you want more information about this particular object, go to that URL. And also, probably I mentioned that. Yeah. So currently, obviously our system only has one resource in it. It just has the mp3s. But you might want to link it to other resources. For example, mp3s actually have artists. An artist shouldn't just be a string in the mp3 table. It should be a link to another table. So what we should have, instead of having artist in the return value from a particular mp3, we should have probably artist underscore name and artist underscore URL, and construct a URL where you can go to an artist page. And presumably within the artist page it would list not only the details about the artist, but also all of the mp3s that are on that artist, and they would all be a URL link back to the URL to the mp3 page. But remember, this is a web API, and so this is creating a web of links to click on to get to help people to explore your API. And it just makes it easier for the clients to walk your data model. Yeah, so I've got an example. In our mp3 JSON we have this, and we probably want to have something more like that.
Or ideally, presumably an object. Yeah.
Sorry?
Presumably you can have a JSON object called for the artist, which contains a URL and a name.
Yes.
Within the.
Yeah. Yeah. I mean, I'm just thinking ahead there. Maybe you want to add a URL method to all our objects so that you can just ask an object what its URL is. Okay, so getting a list of objects is easy. Select star from table. But there are some other things that we might want to consider, and we're not going to consider them in any kind of detail today. We're just going to discuss them. Maybe you want to add the ability to search for a particular object, search but for an MP3 on title or on artist, and so actually return a filtered list. Sorting. We've done nothing about sorting our objects. Paging, which I mentioned earlier, we're going to ignore that because we've only got 3 MP3s, because I have limited tastes. But if you've got hundreds of MP3s in your database, you might want to return only 10 at a time. And so you'd want to add you'd want to add the ability to the URL to say how many you want to deal with at a time, and then within the return data you would return a URL to return the next page or the previous page of results. Other kinds of filtering, maybe only displaying, if we had date information on our MP3s, only returning stuff that's released on a Wednesday. And the way that you would normally do that is by adding parameters to the end of your URL. Those parameters would get converted to options on the DBIC queries that you're passing to the database, which DBIC would then convert to SQL, and then when you get the data back, you would make adjustments to the JSON. That's all assuming that we've got data in our system and we want to get that data out and display it to the user in some way. There are other things that you want to do. We might want to add objects, we might want to update objects, and we might want to delete objects. And when you put that together with the getting objects that we've already talked about, that becomes your standard database CRUD cycle. For those of you that haven't seen the acronym before, CRUD, create, read, update, delete, the 4 actions that you might want to take on a database. Now this is, I guess, something that for a long while there were no best practices in how to do this, and so you might find all sorts of different ways to do it. If you want to delete an MP3 from the database, you might find that you do a get /MP3/1/delete, for example. If you want to insert one, you might you might use post, but you might also use post to update it with a /update on the end of the URL. But actually, actually HTTP, too many acronyms, acronym overload. HTTP contains verbs that we can use to model all of this stuff. So we can post to our MP3 route to create a new MP3, and it would return JSON for the new MP3, which includes both the ID of the new MP3 and more importantly a URL that you can use to go directly to the new MP3. Get MP3 we've seen. Put MP3 ID. So put is a HTTP verb that you don't see very often. We don't see enough. We can use that to update our MP3. And there's also a delete HTTP verb that we can use, obviously, to delete our resources. But the slight odd one out there, of course, is the post is the one that is the only one that you don't know the ID for. And it's actually really not that difficult to write dancer handlers to do many of these. So for example, here is a delete one. So dancer just accepts any HTTP method here, and you're doing all the same thing, and we're getting our result set for MP3s, finding the right one, and doing a delete. I didn't really think about what I was going to return to the user at that point, but that's because we're going to move on to some more complex stuff that does answer those questions. I also pondered for a while whether I wanted to make sure that the MP3 existed before I deleted it or not. But then in the end I figured I was lazy and it doesn't really matter, because if it's not there and I'm trying to delete it, does the user care? Yeah, I mean, it can be hard to get these completely right. For example, what should we return at this point? Is there a better way? And this, I'm going to have to copyright this as Dave's law of presentation or something. Dave's law of training. If a instructor or someone's giving a presentation, stands in front of a class and asks a rhetorical question like this, it's always because the answer is yes. Who's heard of REST? Pretty much everyone. Does anyone understand REST? I'm not even sure I'm going to put my hand up on this one. But does anyone know what REST stands for? Representational state transfer. It's an abstraction of web architecture. It takes some of the ideas that we've been dabbling with over the last hour, and kind of extends them and codifies them, writes them down. It's been around for a long time. The chap that invented them was a chap called Roy Fielding. And he wrote it in a dissertation 14 years ago. It's applicable to all web transactions, but it's particularly applicable to the kind of web services that we're talking about writing here. So a RESTful web service, it publishes a base URL, URI, for the service. Can anyone tell us the difference between a URL and a URI?
URI is more general.
Yes. What does that mean?
URL is a specific instance of a URI. URIs can be different, can have different formats.
Yeah. For our purposes, they're interchangeable.
Yeah. But if you're talking about web services, they're the same thing.
Yeah. So we need a base URL. URI, which in our case would be whatever our host is /mp3. We need to define the media type that we deal with, or media types. In that case, we're just using JSON. We use the HTTP methods for interaction in the way that we talked about a couple of slides ago with get, post, put, and delete. We use hypertext links for linking to associated resources, and that's what I was just starting to talk about doing. Yeah, that's the same thing. You're repeating this one. A lot of web services out there that claim to be RESTful aren't, and there's a good test, which is which HTTP methods does it use. So you see, and I was talking about these just a couple of minutes ago, you often see web services that only use get and post. So you might see something like get the mp3 one, or mp3 one /delete. That's not RESTful. That's RESTful. So if you take nothing else away from this morning, I want you to go back into your offices on Monday and have a look at any web services you might publish and make sure that if they claim to be RESTful, they actually are RESTful. And if they're not RESTful, start thinking about how you might make them RESTful. Because the thing about this is that there's no defined standard. As you see, where does the delete go? There's another option, I suppose, it could go in the middle. And so people can't take knowledge they've got from one web service and reuse it when looking at another web service. Whereas if everyone follows the RESTful rules, then your knowledge becomes transferable. Yeah, so this might be RESTful. It's an indication that whoever designed this web service might know what they're talking about, more than the person that did it. RESTful Dancer. Dancer has a REST plugin, and it's called Dancer 2 plugin REST. There's also a Dancer plugin REST if you're stuck in Dancer 1 world, and it makes our lives much easier. Basically, it does three things for us. It creates routes. It gives us utility functions to deal with return values. And it will also return data in different formats. Creates routes. So it gives us this resource keyword. And we say, we're going to create a resource with that's called an mp3, and it's going to respond to these 4 methods. And for each of those methods, I want you to do whatever the code is in here. And that gives us all of those 4 routes. We don't have to actually define the routes. I mean, we still have to write the code because the code still goes in that dot where I put the dot dot dot. But it's just a nicer way to bundle together the handling for a particular resource. You might even put that code in a separate module, make your Dancer library really slim. Oh, again, the odd one out is the post because it doesn't require the ID. So we might rewrite our code again, something like this. So this is resource mp3 on get, do this, get the parameters. If we've got an mp3, then return status OK with our columns. If it's not OK, return status not found. Now this might be what I was thinking about when I said that it worked fine, because this does the right thing. So back in the resource, there were these 4 methods which generate these 4 routes. But if you don't want one of the routes, you just don't define that key in the resource definition. So here we've only got the get. So that's effectively the same as we already had. We still have to create our own main listing route. It doesn't do that for us. We saw some of the utility functions on the previous slide. So the status OK, and that takes the whatever the reference is that you want to return the data. Status not found with a message. Status created. So if you're dealing with a post to create a new object, a new instance of the resource, and then once you've got the object back, from being inserted in the database or whatever, or however you're storing it, then you can just return that data in the status created method and it will do the write. And it also handles format options. You were asking about YAML earlier. So this it allows the user to choose the data format by just changing the URL. So I said that it implements get mp3 ID, which is the route that we've seen before. But it also implements this route for us at the same time, which is a route with an extra parameter in it, which is the format that it wants the data back in. The support for YAML, JSON and data dumper are all built into Dancer. But it's just a case of what serializers you have installed, and it's reasonably simple to write your own serializer for other formats. Has anyone ever written a Dancer serializer? No. I haven't either, but I'm sure it's easy. So, having written no extra code than the code that I've already shown you on the previous slides, we can do get mp3.1.json, and that gives us our JSON back. But we can do get mp3/1.yaml, and that gives us YAML back. Or we can do 1.dump, and that gives us, we're not quite sure how much use that's going to be if you're sending it to a web browser. Web browsers don't tend to be able to parse Perl data structures. Sorry?
I can imagine it being very useful for debugging.
Yes.
Well, if your client is also Perl.
Yeah, if your client is also Perl, then
Except
you
JSON
can do an
is
eval on
faster
it
than eval, so
and introduce a security problem.
Yes. So, right back at the beginning, when you set a serializer to YAML in the config file, that's basically setting the default serializer.
Yes.
So if you
Yes.
don't specify the URL.
So you were talking about changing the serializer. So that's what this is doing. If you, I guess, if you read the source code to this plugin, you will see it calling set a serializer at the appropriate point. More complicated, we've barely scratched the surface. Coffee in 20 minutes. But Dancer and Dancer 2 plugin REST make this level of REST work really quite easy. And there are other, I mean, obviously, Catalyst and Modulicious and people like that have similar RESTian, RESTful frameworks in place. But actually, full REST support is more complex. Here's the state machine that implements. Does anyone know what I'm going to show? Has anyone seen it?
Yes.
So REST is actually it's easy. It's easier if you think of it as a state machine. And the state machine looks like this. If we just zoom in on the coming in, and you'll see the kind of level at which it's asking questions. Is the service available? If not, return a 503. Is the method that they've asked for a known method? Otherwise, return a 501. This is where, do you remember all those HTTP status codes that you never really understood? They're all on this diagram. Is the URI too long for 414? is the method allowed on this resource 405? Is the request malformed 400? Unauthorized, forbidden, not implemented again. Unsupported media type, request entity too large. Okay. But there's an option, there's a thing here for looking for options. And if that is false, then you go off into this whole new world of pain. And a lot of this is about, I can't even read it, but there's caching and putting e-tags on the HTTP response and deciding whether you need to regenerate stuff and all this kind of thing. And if you want to implement a truly RESTful web service, then you need to deal with this.
Where can that be found, please?
There's a couple of links a little later on that will point you at it. There's also, I've always known a little bit about REST in the back of my head, but about 3 months ago I read this book, and it was really helpful in actually answering a lot of questions that I had about how REST works. So, cpan to the rescue, again. There's a lot to think about when you're trying to get REST right. Can cpan help? Oh, that's the... There's a thing called web machine, and another thing called WebAPI DBIC. So web machine. So I said earlier, right back at the start, that the thing that you hear people saying about the Internet of Things is that it's all written in these trendy languages like Erlang and Scala. That state machine, that state diagram I showed you is from the documentation of the original Erlang implementation of web machine, but there are implementations of it now in many languages. And Stephen Little, who's the chap behind Moose, wrote Web Machine, which is, he basically ported it from the Erlang version, but he stole some good ideas from the Ruby and JavaScript versions too. So basically, it includes a superclass called Web Machine Resource, which basically implements all of those decision points on that diagram. And you write a subclass of those and override the decision points that you care about to do the right thing. If you want to know more than I'm going to talk about in the next 15 minutes, Stephen did a talk about it at YAPC 2 years ago, which is well worth watching, and the slides are on. If you want a definitive place to get that big picture from, if you go to cpan and look at the documentation for Web Machine, there's a link pretty near the top of the description. And then you can use that to scare all your co-workers. So here's a quick example of how you might use Web Machine. And I've left behind the mp3 stuff. This is a really simple web service for finding out the time for people that carry around HTTP clients but not watches. So we use Web Machine, and then we create a package called whatever we want to call it. Use parent web machine resource, and then the JSON encoder. Then the important thing is to tell it which content types we are dealing with. And here we're only dealing with JSON. And we say, if somebody asks for the resource in JSON format, then call this method. And here's the method, which basically just gets the local time and encodes it in a JSON string. And then web machine itself is a plaque application. So we just create a new web machine saying we want to deal with this resource and convert it to an app, and that returns the app reference that JSON, the plaque understands. So we can start this up in ClackUp or Starman or whatever your favourite plaque runner application is. So here we started it up. So we put all that code in something called time.psgi. ClackUp time.psgi says it's accepting connections at 5,000. We curl to 5,000, and I've skipped a load of curl nonsense, but basically you get the headers and then it tells you what the time is. And I thought I'd play a game with myself, and I'm way out. In fact, I've actually... Oh no, yeah. Oh, this means that we're actually ahead of ourselves by quite some time. And then if we decided to say, send us text HTML by fiddling with the accept header, then we get a not acceptable return. This is one of the nice things about REST, is that all of these, as I said, all of these features of HTTP that have been there for decades, that no one's ever used, finally we have a use for them. How many of you have ever written code that looks at the accept header on an HTTP request? 2 of you, 3 of you, 4 of you. More than I would have expected.
I don't think I returned 4 or 6 though.
Tells us something about the authors of the HTTP standard.
With a text saying
they were ahead of their time.
They knew what they were doing, yeah.
So we can change our code, and we can. So this was the content types provided. We did this one. We can add. Say that we deal with text HTML, and then we can add a to-HTML function. And do not do this. It's just an example. Embedded HTML in your Perl code. Terrible, terrible, terrible idea. If only there was a really nice templating engine, or perhaps a good book with a badger on the cover. But so basically, all we're doing is getting the time and embedding it in a really simple piece of HTML. And now, when we run the same command, we get our HTML back. So, web machine hides all of the scariness. Of that horrible, horrible state diagram. WebAPI DBIC takes it all a step further. This is from the documentation. WebAPI DBIC provides the parts you need to build a feature-rich, RESTful JSON web service backed by DBIC and skills, which sounds like exactly what we were trying to do an hour ago. It's a REST API in a box. It's written by Tim Bunce, which therefore means it's wonderful. And it works. It's built on top of a web machine. It uses a thing called path router. And plaque, of course. It uses JSON and HOW. Now HOW is a thing called the Hypertext Application Language. It's a slight extension to JSON. It basically talks about defined formats for returning. You know, we're talking about those embedding the URLs to related resources. Well, HOW is a way to embed those in the JSON in a standard way, such that any client will understand them. Any HOW-aware client would understand them. So trying it out, I guess you can install it from CPAN, but it's reasonably new and moving quite quickly. So cloning the GitHub repo seems like perhaps the best option. Then you install module CPAN file and install the deps and wait, because it installs quite a lot of dependencies. You export a variable. This is the example that comes with the system. And it comes with this WebAPI DB any.psgi, which is a Web API test. Well, basically, it's the Web API in a box that we talked about. Because once you've started that, you can open a web browser on port 5000 and just browse the API. It shows you all of the endpoints and all of the links between them. Now, what I really wanted to do at this point was to actually show you some browser shots of this in action. But unfortunately, I was installing this quite late at night and I didn't have time to actually get it up and running, so I haven't been able to give you any examples. And Tim doesn't have a online example, which I was hoping to cheat and leap in. But this is how it works with the dummy schema that comes with the CPAN distribution. Look, because it just works on DB through DBIC classes, and it interrogates the database to find out the relationships and things like that. You don't have to change the code at all in order for it to be a web API to your DB classes. So you just set the name of your DBIC schema to something which is on the library path. Go around and find it. Turn off the authorization so that it's easy. Not on a database, not on a server that's connected to the internet. Set up your DSN for the database to connect to. Set a couple of other things. But this is exactly the same example that we used on the previous slides, and it just works. A built-in in a box, just point it at your DBIC classes, and there you go. You've got a web service that supports all of the standard things you might want to do. Sorry.
Can you use a config file for all these? All the things that you're exporting. Is there like a config file?
I haven't dug into it to investigate that. You would hope so. Wouldn't you?
This looks a bit nasty.
But if not, you just stick it in a file, shell script. But there's a GitHub repository there. I'm sure that patches would be very welcome. What else? So the last time we had a London PM technical meeting, we held it at Conway Hall. Who was there? A couple of people were there. I was there. A chap called Mike Francis gave a really interesting talk about how he had implemented a really nice sounding web API on top of basically a DBIC schema, and all the problems that he'd gone through, and how he'd solved them, and how he'd done all the reading around REST and come up with the best way of doing it. And so it sounded really good. And it went to the question session at the end, and someone put their hand up and said, have you heard of WebAPI DBIC? It seems to do everything that you wanted. Which is kind of sad, but you learn by reinventing things.
That's the story of most Perl devs' lives.
Yeah, but the lesson is, of course, CPAN is your friend. But I admit I hadn't heard of this until...
I think Tim had released it earlier that week. It was very, very bad timing. Or good timing.
Well, I said I was going to let you out a little bit early. It's almost 11 o'clock, and actually I've run out of slides. So we just do this, and then you don't need to come back for the last 20 minutes. How does that sound?
Yeah.
Unless anyone wants to come back and discuss things. So anyway, always great for the Internet of Things because it's great for text processing and network processing, and that's what HTTP is. And Internet of Things apps are mainly HTTP transactions, and Perl, as we know, is good at those. And CPAN is your friend. There are really powerful tools on CPAN that make doing this stuff really, really easy. Oh, quick plug. I'm running, if you've enjoyed this, or you have colleagues that might enjoy this, I'm running some Perl training, and I know it's really short notice, it's next week, but there's an advert in the brochure with a link. Probably people here definitely don't need the intermediate Perl, because you're all at that level easily. Probably you don't even need the advanced Perl, but you've all got colleagues who might find it useful. There's an advert in the brochure. If you didn't get given a brochure as you registered, then they put them on the registration table, and they'll be taking bookings on Monday. Yeah, next week. Thank you very much for listening. I'm sorry that we finished basically 20 minutes early. I hope it was useful.